Hello everyone, I'm back again. I'm Kelvin, the statistician and analyst. This is my fourth project, and today we're gonna look about the hyperparameter tuning with a multiple linear regression. Please, if you have not subscribed to my channel, please subscribe, like, comment, and share. So in this fourth project, we'll be tuning the several models for multiple linear regression. First model is OLS linear regression, which means ordinary least square linear regression. The second one is Lasso regression. The third one is a ridge regression, and fourth one is elastic regression. We will do this once we will able to apply some powerful techniques such as pipeline and a GridsearchCV for model selection. Also, the previous project, the first project was simply linear regression. It was just a simple linear regression. The second one was simple linear regression model with Microsoft Excel. And the third one was just a multiple linear regression, and we explore it exclusively in terms of statistical formula. Now this one is more technical, and we are looking for best model ever based on the evaluation metrics here. So OLS linear regression is just a normal linear regression which is made possible by applying the statistical formulas. The second one, Lasso regression, is whereby we are reducing collinearity. This one which add a penalty, which is called penalty. Both of them, Lasso regression and ridge regression, they both have penalty, but there's some advantages which arises from the two methods. Hence, we use Elasticnet regression. Elasticnet regression provide a trade-off between Lasso regression and ridge regression. So now let's get started. So first of all, I just there is the first chord above cell. So if I hit shift enter, then I'll just wait for a few seconds. Then this is my name, Kelvin Tipson, the statistician and analyst. Now let's move forward. Now here, let's get started now. This is the fourth project, just as I've said. And now we need to fill these gaps. We're able to have a complete project. Okay, now we will so I will share with you this question of this Python code. If you are confident enough, you can go on with working ahead of me, and if you're not, then don't worry, we'll go step by step together. Okay, let's now start. So I'll import pandas as pd. This for manipulation, data manipulation, and this one is numpy for numeric Python, and p, and this one is matplotlib.pyplotsplit as plt for visualization. This one is I've just repeated these ones. Oh no, it's called RSC params. Yeah, the format is the same, only that we're adding a different package import. Yeah, RSC params. Yeah, that's exactly what we are looking at. Next one, we will import sklearn for preprocessing, import standard scalar. This for normalization, standard scalar for normalization of dataset, standard scalar. We have to ensure that we have the right standard scalar. Yeah, it's correct. Next one, from sklearn.model.selection, in this case we are going to import two formulas, and the first one is train underscore test underscore split. The next one, this for splitting, for partitioning the test set and train set. The second one is for model selection. It's called GridsearchCV. That's it should be written in the sentence case. GridsearchCV should be here. Oh, capital C and V. This is sentence case. The next one, from sklearn.pipeline import. This case will import a pipeline in two ways. This pipeline, and the other one is make underscore pipeline, and then here down here we want sklearn.linear underscore model. This is where we will able to import our type of linear regression, and we will import. We have mentioned there are 4 types, and they are these ones. So now here down here I will start with linear regression. It's also written in a sentence case here, regression. And the second one, Lasso, capital Lasso. The next one is Reg, capital Riege. And the last one is Elasticnet. We also going to write this one in sentence case, Elasticnet regression, or it should be Elasticnet only. That's way. So next, we'll find a way of evaluating the above models, these models, and the first method of evaluating will use mean underscore squared underscore error. The second way of evaluating will be R2 underscore score, and the last one, if you use this method, is mean underscore absolute underscore error. So now we have done with this. I'll just add area. Now I'll just hit shift enter, and the will run. Let's wait for a few seconds. There is an error. Let's check where the error is. Cannot import name RC params. So here I forgot to add params. So if I hit shift enter again, then wait for a few seconds. Let's wait if it's going to work. Let's wait. Yeah, there is also another error. I don't know why it's bringing a lot of error. Grid search. Oh, I misspelled this one. Grid search. It should be search for looking something. Search. Then this one's that's way. GridsearchCV. If I hit shift enter, don't know why. Yeah, now I hope it's going well. Yeah. So we have successfully loaded our packages. So what's remaining now is to import our dataset called advertising advertising.csv. Here should be capital A here, uppercase A here. And if I hit shift enter, advertising, this here spelling. Yeah, now we upload our data successfully. So next, now here we require to partition our data set into the futures predictor variables and dependent variables, independent and dependent variables. So here we will start with dependent variables. In this case, now we want to predict the sales based on the advertising channel using TV, radio, and newspaper. Now we want sales. I just use df.sales here. Next, I'll use ilog to access the TV. TV start from, remember Python start from index 0, so it's column 0, column 1, so I'll start with 1 here, then 2, write 2 here, then 3, and that's end. So we're having 3 explanatory variables, and if I hit shift enter, then we have partitioned our data successfully. So the cells has only a single column and 200 rows. Then explanatory variables or independent variables has 200 rows and 3 columns. Now let's move to the next step. Now here we need to partition our data set into train set and test set. So here we'll use this our formula, train underscore test underscore split. Then we put here independent variable, then target variable y. Then here we'll use an argument called test and underscore size. And if I hit shift enter, then we have successfully partitioned our data into train set and test set. Now we're on a good track, we're in the right track actually. Let's move on. Now here we want to wrap all of the pre-processing methods such as standard scalar and all of those models that we have. Now pipeline or make underscore pipeline is the only function now which is to help us to put all of these models together instead of repeating each and every model in every now and step. Then we compare the evaluations. Now we're going to do this once. This only made possible by using pipeline. It's a very powerful tool for machine learning, and it's enables us to have a few codes, but which is very efficient, manageable, and it avoids tedious and lengthy codes, which sometimes it will lead to confusion. So that's why we will improve the use of this pipeline function for machine learning. Now let's put all of these models in the pipeline, and then we'll put their possible parameters down here. Now let's know now how do we use pipelines. We use any name here, like now I've used the name pipelines, then I equate it with a dictionary data structure. Then I use the name of the models the way I want to call the first model. I will call it linear, the second one I'll call it Lasso, the third one Ridge, and the last one Elasticnet. So here in the linear regression, this used linear as the keys, and the second part whereby supposed to have our values, I will use this function, this name of the pipeline function. And in the case now, this case now I'll apply the use of make underscore pipeline. So here make underscore pipeline equals to, then I open parenthesis, I open this brackets, then here I put inside a standard scalar. I want all of these models to be equal. I'm treating them the same. That's why in each and every models here 1, 2, 3, 4, I've just added standard scalar. Then here is where it distinguish the models from the others. So here I will use the name of the models, and in this case now I'll use linear regression, just the way linear regression. Then now I have to instantiate it. Yeah, the first one is linear regression. So the second one here, it's a lasso. Now I'll put lasso. So then inside I'll just add random underscore stats equals to, I'll put my preferred value, which is 42. You can also put yours, but so that you can have the same answer that I'm having, you can put the same as mine. Now to range, I'll also use the range. I just instantiate, then put random constant equals to 42. Then here down the last one here, I'll also put the same, but this one is Elasticnet. Elasticnet here also have the same random stats equals to 42. Yeah, so now I think ready to go. If I hit shift enter, then we have successfully put all of our models and pre-processing, that is standard scalar, together in the pipelines using a powerful function called pipelines, and also the dictionary data structure. Okay, now let's move to the next step, whereby we need to create the dictionary data structure that store all the possible parameters for each and every possible model parameters. So now this is where we need to understand what each and every model, we need to understand what each and every models and their corresponding parameters. In this case now, now linear and hyper. In this case now, I'll just use the default for OLS parameters. I will not add any parameters for OLS, the first model. And the second one, I just use the name of a parameters called Lasso underscore alpha, and these are the values which are used. And the second one, region underscore hyper, I just use just the same as this one, only that this is a range underscore alpha, region underscore alpha. And the last one, I'll use two parameters, or three, sorry. The first one is Elasticnet underscore alpha, and the second one of this model use also Elasticnet. But there is something that I have to make it clear. When we are using parameters for the models, we need to put here double underscore, like this one was having one, so I have to put this one and this one so that it will work. And this one I'll just put first one, second one, The last one also in this last model, I also have to put 2 underscore first and second, and also in this one just put first one, second one underscore. Then I'll put parameters called L1 underscore ratio. By the way, and the last parameter for Elasticnet will be Elasticnet underscore max underscore height. So what? Be careful. Ensure here it's double underscore. That's why. Now we're ready to go. We have done with this one. So you can use your preferred names here. Like mine, I've used Lasso and alpha. This here I've used just use the linear, but this one has no any parameters. So if now we're ready to go, if I hit shift enter, now we have successfully created the parameters for each and every models that we have stated here above the pipelines. We have stored in the above pipelines. Now here we can create another dictionary whereby we will store all of these models, all of these parameters to their corresponding models within the pipeline. Now this linear is within the pipeline. Now we want to equate it with the values of their corresponding parameters. In this case now here linear is equals to linear underscore hyper, which is this one. Now this one just copy and then I'll paste here that way. Then here I hope if I'm not, oh no, just here just use Lasso underscore hyper, this one, I'll use reach, I'll equate it to reach underscore hyper, everything underscore hyper. If it's Elasticnet, then it will be Elasticnet underscore hyper. Then this one I'll just highlight, Control C to copy, then Control V to paste. And if I hit Shift Enter, then we have stored our models to their corresponding parameters. Now let's now test if the corresponding models is fitted to their is connected, if the corresponding parameters is connected to their respective models. Now we'll use this function. We will create an empty name or an empty dictionary which will store all of these models. So now here we want to test if the models within the pipeline is connected to their corresponding parameters, and this is how we will do it. Now this empty dictionary will equate it with, now it's time to use a GridsearchCV which it's do well in this, in connecting these models. GridsearchCV. Now I'm careful to avoid errors. GridsearchCV, capital CV. Now here I start with name of the pipeline, which has stored our models pipeline. Then just put here key, then here I'll just use parameters key, that's way. And if I hit shift enter, but I'm seeing there is an error. Let's see where the error is. Pipeline. It was pipelines. It has the S in the last. So now we have already we have checked, and it has the connections. The models within the pipeline has connection with the parameters, which is stored in this dictionary. Now let's move forward. Let's go on with, we're in the right track now. Now what we're remaining with is that we want now to train all of the models at once, and this is how we will do it. So now we use the fit function from sklearn to do this job. Okay, now models dot fit, and the function take two arguments, train set for independent variables and dependent variable for train values for dependent variables. And if I hit shift enter, now model is all of these models now train. Next, let's move to the, now we want to evaluate our models. Now here we store values to this an empty dictionary, whereby it will summarize all of these evaluation method. If I hit, there's nothing to edit here, or there is here. Now we'll head it to these ones, where it's called, we'll use predict function to get our prediction. Predict, of to write it well. Predict, predict, it's a repetition here. Predict here. Now if I hit shift enter, now we have our summary. Let's see now which model is doing well. We should avoid using this R squared, because this one means as variables for independent variable is increasing, also this value increases, hence we should not consider using R squared. Now let's use both of these, mean square and mean absolute error. Which one has the least value? And that's the best model. Now this 3.79 here, 3.6, 3.79, 3.72. Now I can see this the minimum one. Let's see the mean absolute error 1.5, 1.4, 1.5, 1.449 is 48. Now the best model now is a Lasso model. This is the one with the minimum mean square error, which means that it has a higher predictive power. Now we have know that our model has selected Lasso as a method of predicting these values. Now let's move on. Here want to see the keys or summary for models. Now here let's see the summary. Summary, it's here, linear. Now let's format it nicely. So if I hit, now here I want to compare graphically by use of kind is equals to bar. If I hit shift enter, let's see. Now this underscore, this one is mean absolute error, the yellow one, and the green one is mean absolute error. And if you use your own eyes, it's difficult to see the difference as it's roughly equal. Let's find another way of seeing these values. Now if we look at this value now we can easily compare this value now here. So here we selected Lasso regression. We can see that the Lasso regression has minimum mean square error, mean absolute error compared to the other models. Now ready to move forward, ready now to proceed and move forward with our models now. So if I hit now, next step, let's apply the best method, which now it's Lasso. Now I can put this Lasso here and predict the dependent variable. And if I hit shift enter, no, there's a problem, there's a typo error. Lasso, at least written well. Lasso. I want to see where the problem is. Lasso. See where the problem is now. Oh no. Now that's not how I rename my pipeline. The pipeline is here. How did I rename my pipeline? The models are here. I use this Lasso. Control C to copy then and move downward, and I'll paste here. So select here and paste here. Now if I hit shift enter, what's the problem? No, I didn't put the square bracket here. If I hit shift enter, now we have saved our predicted values. Now let's move forward. Let's visualize the difference between the actual and Lasso predicted cells. Now we'll create the number of observations. Now we want it to have NP with a powerful formula called arrange to create a 60 values, 0 to 60. And if I shift enter to save, here I will use this val here as a X value, horizontal value. Then I will compare this value. So now I want to plot this val as horizontal or X values. Let's predict. Then I'm comparing the Lasso prediction here, these ones, and I want to compare with what we have predicted here, y underscore test. If I hit shift enter, now we can compare the predicted values of the actual values. Now let's see. You can see that it's actually doing well. Yeah, and this how we can use the best model among virus or among selected models, and we can proceed forward with the best one. So guys, thank you for taking your time to have this video, and this is my fourth project. Thank you guys. Also don't forget to subscribe, like, comment and share. Let's meet in the next video, which will be project 5. My name is Kelvin Kipsang, the statistician and analyst. Let's meet in the next video.